Hello everyone and welcome to this video of the course Robotics. In this video, we are going to work on a practical example of controlling the angular movement of a robot using delay and PWM. So for this case, we'll be sending simple instructions to the robot, and based on that, every instruction will be programming the robot to take a turn with certain times of delay. You might have already noticed that when when you ask a robot to take a right direction, it keep on turning right until unless we stop it. So if we can control the time for which the robot is turning right or robot is turning left, we can control the angle that the robot is taking while turning right or turning left. So we are going to control the angular moment of the robot just by controlling or varying the value of time delay and the value of PWM combination part of it. For that, we'll be programming a robot in a similar way, and simple will be sending the signal to it in using CL communication. So we'll be expecting a robot to take a turn based on the signal that we provide. So let's get started with that. So for this example, we'll be using two motors into the robot, and for which we'll have to program 4 pins of Arduino to control two motors. So the pins that we'll be using will be PWM pins on pin number 6, 9, 10 and 11. For that, we'll be declaring the pin numbers in M11, M12, M21 and M22, and then we'll be declaring the pin mode, and then we'll be going on. So let's get started with that. The first part that we'll be doing here is declaring the pin numbers out here. So M11 equals to 6. Similarly, int M12 is going to be equal to 10, and it will be 9, and then it will be M21 will be 10 and M22 will be 11. Once you are done with this, now we'll go to void setup part and declare the pin mode of every pin. So pin mode of M11 is gonna be output, pin mode of M12 is gonna be output, pin mode of M21 is gonna be output, and pin mode of M22 is gonna be output. Once we're done with that, declaring the pin mode of every pins that we have declared so far, which we are going to use, now will be then thereafter we'll be declaring the baud rate, because we are going to communicate with the robot via some mode of UART communication. So for that we'll be declaring the baud rate to be 9600 bits per second. In void loop part, before coming to void loop part, we'll define some functions like light, left and stop, and then we'll come to void loop to use those functions and program something. So let's say that first of all we'll be defining the function for the robot to take a right turn. So in a right turn, it has to make one wheel moving and another will stop. So we'll first define some functions for right, left and stop. Let's get started with the right function out here. So for that we'll be writing in the standard format, that is void right, and as there will be no input argument, we'll be keeping empty braces, and in curly braces we'll be defining the function part. So in right condition we'll be making one motor move one another stop. For that we'll be writing distal right M11 low and analog right M12 kind of 200. So we are going to control the PWM actually over here. Rather than writing distal right M12 high, we'll be writing analog right M12 200. And then for keeping the another wheel stop, we'll be putting M21 as low and M22 also as low. So for this we'll be writing digital right M21 as low and digital right M22 also as low. Now, once we are done with right function, now it's turn of defining for defining left function, for that we'll be writing simple void left distal right m11 as. Now for left part we'll be taking first will stop and second will moving. So for that we'll be taking m11 as low, and also distal right m12 also as low. And for next wheel, that is for second wheel, to keep it moving we'll be writing distal right m21 as low, and for the another wheel, rather than writing distal right m22 as high, we'll be writing analog right m22 as value 200, so that the robot will move slowly. When it's moved slowly, then it is easy to control the turn part. Now we're done with the left turn. Next we can program for stop function. So for stop function we have to make both the wheels stop condition. So for that we'll be simply writing digital right m11 as logic low, and digital right m12 as logic low. Similarly, digital right m21 as logic low, and digital right m22 as logic low. So once we are done with the stop function, now we can start using these functions right, left and stop to control the bend of robot, or you can say the angular turn of the robot for certain amount of turn. So let's say that we start with serial communication. So when serial data is available, that is while serial dot available, it means when serial data is available, then only you want to read the data. So when serial data is available, we'll be writing data is equals to serial dot read, and the data type for data will be char. So we'll be able to read the character by character part over here. And then we can compare, for example, let's say that if the signal sent from the PC is R, the robot should take a right turn. If it is L, it should take a left turn. If it is S, it should take a stop. So let's program it for R first. So if the data sent from PC is R, the robot should take a right turn, and for that we'll be calling the right function over here. Similarly, in next case, let's say else if data sent from the PC is equal to L. In case of L, we'll be making our robot to take a left turn. For that, inside this condition, we'll be calling the left function out here. Next is if data is equals to S. In this case, we'll be making our robot stop. For that, we'll be calling stop function over here. Stop seems to be kind of a predefined tag, so we'll be making it doesn't stop to stop robot, and here also we'll be calling a stop robot over here, so that it should not interact with any other of the predefined tag or predefined keywords in the Arduino. Next part, let's say that now you want to define something for a certain signal sent from the PC. The robot should take a certain angular turn. For that, we have to control the amount of delay for taking turn. So let us say if else if data is sent which is equals to A. Now in case of A, we'll make the robot to take a right turn, but only till half second, only till 500 milliseconds. After that we'll stop the robot. So for that we'll be calling the right function first. After the right function we'll be giving a delay of 500 milliseconds over here, and then we'll be stopping the robot by calling stop robot function. So in this case robot will taking turn only till half second. So that will generate a certain angular turn. We'll be analyzing that what turn it is exactly. Next case, let us say that else if the data sent from the PC is equal to small b, in that case again we will be taking the right turn, but this time compared to the last time where the delay was only 500, here we'll try to increase the delay to analyze that how much more angular turn the robot is taking. So we'll be first calling the write function and putting the delay of let's say 800 milliseconds over here, and then again calling the stop robot function over here. Next case can be, let's say that else if the signal sent from the PC is or data is equal to small c. In this case we'll again be calling the write function, and let us say that in this case we want to put a delay of around 1 second, that is 1000 milliseconds. So we'll be calling the write function, putting the delay of 1000 millisecond over here, and calling the function stop robot. There can be one more function we can call over here. Let us say that in case else if data sent is equal to small d. In case of small d, we can make something like the robot to take a direction and a delay of around 1200 millisecond, and then stopping the robot. So let's say we make around 1200, yeah, 1200 we defined as 1500, so let's make it 1200 only, and then stop robot function will be calling up. So let's say these are the couple of turns that we want to analyze for right turn, and similarly we can also do for left turn as well. So let us say that in case of left turn we will be comparing some other keywords. So let us say that if data sent is equal to after d, let's take small e. So in case we having small e, in this case of small e, rather than taking right turn we'll be taking left turn over here, and for that we'll be calling the left function over here. That is what we have defined. And after calling left function we'll be putting a delay. Let's say in beginning part we can put a delay of around 500 milliseconds, and then call the stop robot function. Similarly, let us say that else if data sent from PC is equal to small f. So when it is equal to small f, in that case also we'll be making a robot to take a left turn, and then putting a delay of around 800 milliseconds over here as well, and then calling the stop robot function. Similarly, in next case we can do something that, let us say that else if data sent is equals to small g. In that case we can again call the left function, and rather than 800 milliseconds delay that we have put last time, in case of g we'll be putting a delay of let us say 1000 milliseconds, as similar to right part. So first we'll call left function over here, and then we'll be putting a delay of around 1000 milliseconds, and then we'll be calling the stop robot function over here. Similarly, last case we can also program one more case over here, that is else if data sent is equals to small h. So in case of small h, we can program the robot to take a left turn, and after left turn put a delay of 1200 milliseconds, and then call the stop robot function. So we're done with programming the robot for different directions, and this is a full program for doing this. You can scroll up the program and check out it. Let's save the program and simply compile the program to check if there is any error or not. We'll go and compile the program. After compilation part, we'll upload the program and try sending signals to the robot via Bluetooth. The connection of Bluetooth will be clear to you in next coming videos. Right now you don't need to go about Bluetooth part. In general way, I'm going to just attach a Bluetooth device with my robot and pair it with my PC and send signals from PC. So once the program is compiled completely, we can upload it up to the Arduino. So we are done with compiling. Let's upload it to Arduino. Check the tools, port is selected, then you can simply upload it to Arduino. So once we're done with uploading, now we can check the robot and send it different signals and try to control that and try to see that whether it is taking a certain angular turn or not. So let's check the output now. So now we are going to check the output of the robot by giving it different signals out here. So let's check out that one. For that, we'll be opening the CL monitor of our computer by selecting the Bluetooth port. So I'm going to select my Bluetooth output port over here, and I'm going to pair from my monitor. Here you can check the output in the robot part here, and let me give it a signal of taking slightly right turn by sending it A. So let's see how much right turn it takes. So let's check for A. So for A, the robot is taking slightly turn. Again, if I send A, it's taking slightly more turn. Again, if I send A, it's taking slightly more turn. Again, A is taking more turn. So again, if I send A, so now it is kind of 90-degree bent from what was the previous position, that is 4A. So you can say after 500 into 4, that is 2000 seconds, it is taking the complete 90-degree turn. So let's pull it back by sending the signal like A, B, C, D were for right and E, F, G, H for left. Again G. So this should come completely perpendicular, which you can see over here. So if I again send G, it means for 2000 seconds it's going to take 90-degree turn. So again G. Again G. That is 90-degree turn. If I want to take again 90-degree turn, again one G for 45. It means G is giving it 45, again 2 multiplied by G is giving complete 90-degree turn. Similarly, 45, and this is another 1000 seconds is going to give 90-degree turn. So you can say that 1000 milliseconds is going to give it a turn of 45 degree, and 2 multiplied by 1000 is going to give it a turn of around 90 degree. So in this way, 500 should give it a turn of around 22.5 degree. So let's send A again. Second A, third A, fourth A. So this fourth A should actually give it 90 degree turn, but it is not visible into the range. So I'll bring it back. We'll again send the robot signal of A, second A, now third A, now fourth A. So you see after 4A it is taking a turn of 90 degree, and that shows that A, that is 500 milliseconds for this sort of motors, is going to give it a turn of around 22 degree, and 4 multiplied by A is going to give it a turn of around 90 degree. Similarly, we can also check for what happens for B part. So we can check for B. So that will give a turn of around for 800 milliseconds, and similarly for C, it will give for 1000 seconds, and for D, it's gonna give it a turn for 1200 milliseconds. See, when a turn of 90 degree can be taken by giving the signal B and D. So let's give it B first, that is for 800, and then D for 1200. So that should give a complete 90 degree turn. That is what we are getting over here. Similarly, for getting the 90 degree back, we can give the signal F and H. So these two should bring it again back to 90 degree. So this is somewhat we are getting out. This is how you can control the different angular moments by giving a different delay and PWM combination. So thank you for watching this video, and stay tuned for more videos.